We'll proceed in primitive calculus. So calculus that actually started with algebra, and then we forced to find one other way also. Primitive calculus. Calculus when it originated and then it took one more form. So there are two forms in calculus. Both forms we will talk. So one form we have seen that there are three ways we can do addition upon. Three ways. One is addition, another is multiplication, and third is calculating the area. When it comes calculating the area, then uh, third one. So when it comes to calculating the area, then there comes algebra, because in if I want to calculate the area, then there has to be two sides of it. One side is horizontal side, one is vertical side. Horizontal side is called independent component and vertical side is called dependent component, algebraic equation, function over independent component, whatever is suitable, height, whatever. So if there is an independent component, if there is independent, this is independent component. If there is independent component and function over it is like this, means at each value of x there is fx or y. If I connect all the fx, then it becomes like line like this. If this if this portion is the origin, then then okay, what is the net addition? We talked about it. So this function, the function what we are saying, this function is collection per unit of this. So if this x-axis is our, if this x-axis is our time t, then this function over it is ft, function over t. Now, if person is walking 2 kilometers per hour, then when t is 5, at this moment, okay, how much distance he has covered? Distance covered is whatever the area we are seeing, that is the distance. If I have collection per independent component is time r, then collection per hour. If I have graph of collection per hour, then how much collection has been made, that is the area. Area, calculating the addition collection through the area, it is also called integral calculus. Integral calculus is nothing more than a representation or notation that shows the calculation of the area. If this is ft, function over time, and this is t, then calculation over area is nothing but ft into t. Since ft is variable, it is not a straight line. It is variable, the height is variable, so the area will be again a algebraic equation, certainly. So now, what is the area? If there is a height and there is a width, then height into width is area. If there is a height and there is a width, then height into width is area. Here height is ft, which is variable at any t. It's not constant. So ft into t is the area. Rather than t, we say dt, because it is variable. So ft, function over t, dt is the area. This is integration. We place our snake sign claiming this is lower limit and higher limit of the area. By default, the lower limit is origin and higher limit whatever we want to be put. Not required. Means higher limit, lower limit is not required. We can get pure algebraic equation as the net collection. The reverse of if I do ft dt and it comes as another algebraic equation, that is gt, ft dt gt or fx, integration of fx along x-axis results in gx. Then from gx, if I get back, if I try to get back fx, fx fx is a function. If I do integration, it resolves in gx, another algebraic function. From gx, if I do something, then it will result back in fx. This is called derivative. If this path is called integration, this path is called differentiation. Integration is analogous to multiplication, whereas differentiation is analogous to division. Okay, so fx into dx result in gx, then gx by x results in fx. Simple, right? Fx into x results in gx, then gx by x result in fx. Fx into dx result in gx, then dgx by dx result in fx. One is integration or antiderivative and one is differentiation. So this is integration and differentiation. What is the most basic in calculus? Integration, because it calculates the addition through multiplication, calculating the area. Since the algebraic equation for the where we calculate the area, if this is the line, an algebraic equation of this curve is not straight line, so it is varying. So we give notation that ft into dt, not t, dt. That is calculus. And here gx by x or gt by t, we don't do dgt by dt. That is division. So division turns into differentiation and multiplication turns into integration. So this is calculus, straightforward. Now, now if fx, whenever we do integration, we consider function is rate of change, rate of collection per hour, and we calculate the area, then resultant is the collection. When we do differentiation, we know that is the collection. When we do differentiation, then collection per hour is the differentiation. Integration, collection per hour, it converts into collection, and differentiation, if it is collection, it converts into collection per hour. Hour is independent component per independent component. So calculus identifies in algebra independent component, dependent component. Independent component is, if we say x-axis, then dependent component is y-axis, orthogonal to the x-axis. Okay. Now this is the case. Consider now the fx, left side fx, I am doing integration. Fx is x. The function fx is x. If this is x-axis, fx is x, then this is the x equation. This is x-axis and fx is x. The line that represents x is like this. At 0, it is 0. At 0, it is 0. At 0, it is 0. And then it starts growing the way x is growing. What is the integration for it? That is area underneath. Okay, so we have seen now that integration of x to the power 0 is x. Integration of x is x square by 2. So integration of x to the power 3, x to the power 2 is x to the power 3 by 3. Means the integration rule for polynomial equation is x to the power n, integration is x to the power n plus 1 divided by n plus 1. So if line is fx is x, then integration is x square by 2. What is the sign is fx into dx, then integration sign. So fx is x, x dx, x into dx. X is height and dx is x-axis. So height into x-axis, then it becomes x square by 2. Fx integration becomes gx. Fx is x, then after integration it becomes x square by 2. Gx is now x square by 2. If I do differentiation of gx, then it should become fx. Now gx is x square by 2. If it is collection per hour, then gx is net collection. If it is net collection, I want to get collection per hour, then I have to divide it by the independent variable. Here I multiplied fx into dx, multiplied with the independent variable. If I divide with the independent variable here in gx, it will bring the fx. Differentiation now this side. Now gx is x square by 2. If I divide by x, then it will become x by 2. That is not the fx. Because this, if this is x-axis, then fx is straight line, that is x. If this is x-axis, then this is fx, that is x. At any moment, it is x. If that is the case, then fx is an algebraic equation. Okay, fx is not flat line. If it is a flat line, then it is all right. I can do gx by x. But if it is not a flat line, it is a kind of a slant line, then there is an issue. If there is a slant line, then there is an issue. Okay, if there is an issue, if there is it is a slant line, then if fx dx is x square by 2, directly I cannot divide by x. There has to be differentiation. Okay, now you see that the area, if x is fx, then area is x square by 2. Fx is variable with x, that is means equation of fx equal to x, and x is vary as per we change the x. Now the area comes is x square by 2. X square by 2 also changes if x is changing. Now let's draw the curve for the x square, that is the area. If this is x-axis, then x square is like this. If this is x-axis, then x square is like this. X square, if x square, if I see x square, the vertical component, it is not a flat line, it is not a slant line also, it's not a straight line. It is a kind of double degree. Okay, so it is a kind of non-linear, you can say. So if it is a non-linear, then it is x square by 2. If that is the case, then area, this is the line I draw for the area, that is gx. Now gx, if I divide this gx by x, then it will come as x by 2. That is not the fx. Fx is x because it is variable. It is not non-linear. If fx was k, straight line parallel to x-axis, k, then integration is kx. If I divide it by x, then it becomes k. So kx, the area curve, kx is a slant line, straight line, like this. If I divide it by x, then it will give a horizontal k. But if it is a non-linear, then I cannot divide it by x. So this area is variable. It is different. What it is variable? Question comes, why I cannot divide by x? Consider that fx function is k, a constant. If I do integration, it becomes kx. Kx, if I divide it by x, gx, if I divide it by x, it becomes k again. K again. Okay. So what I'm trying to say is kx, if I draw the graph, it is a straight line and slant line. Now if I take 0, if I take 0 to 10, 0 to 10, one strip I take. Now if that is the case, then if I divide it by 10, then it becomes area become, when x is 10, the gx, the area become k into 10, that is 10k. If I divide it by 10, then it becomes k. Now if I take 5 to 15, 5 to 15, then k 15 minus k, I'm sorry, if I take 10 to 20, I took 0 to 10, I now take 10 to 20. If I take 10 to 20, then it becomes k20 minus k10 back, divided by 10, again k. So no problem. If gx is kx, then if I divide by x, then it becomes fx, that is derivative. Now if it is x square by 2, now take x as 3, 0 to 3, then 9 by 2, that is 4.5. Now again take 3 to 6, 3 to 6, then 6 square by 2, that becomes 18, 18, and x square by 2, that becomes 4.5. So earlier x square by 2, x square by 2, if I take 0 to 3, then it becomes 9 point, it becomes 4.5. 4.5 divided by x, if I'm trying to calculate back. So x square by x square, x square by 2, that is the gx. If I divide by x, it becomes x by 2, x by 2. Now let's calculate x by 2. Differentiation is x by 2, or I think I should demonstrate in little different way. Now consider it is k, then it is kx. Kx, so kx is a slant, kx is a slant straight line. Now 0 to 3, let's see, take k as 1. So it is x. Now if I take 0 to 3, then x becomes 3. 0 to 3, it becomes 3. Now 3 to 6 you take, then again it becomes 3. So this is kind of the increment what we see in gx. Gx is x. When it is 0, the x is 0. When it is 3, then x is 3. When there is 3 increment along x-axis, then 3 increment along y-axis. Now I take 6, x equal to 6. If there is a 3 increment here, then here it is 6 increment. So again 3 increment 1. So it is constant. Now if it is x square by 2, 0 to 3 if I take, then 3 square by 2, it is 4.5. Now 3 to 6, again next 3 I take, then 6 square by 2, it is 18, and 3 square by 2, then it is 4.5. 18 minus 4.5, it is not 4.5. So if I take different interval, then rate of the change in vertical as per the horizontally, keep horizontal 3 3 3 3 slab interval, the change in vertical is non-linear. If that is the case, if it is everywhere the change is different, then what we try to do, if integration is calculation of area, then differentiation is calculation of area rate of change in the area. If it is, if integration, if fx is collection per hour, if I do integration, it calculates collection. Now if there is a collection, then if I do differentiation, then collection per hour, we get back the fx. So collection per hour means that if there is a x square line, if there is a x square line, there is a line called gx, then if there is a unit change along x, if there is a unit change along x, how much change gx is showing, that is differentiation. Dgx by dx. If at any point x, at any point, this is x-axis is true, at any point x, or if I say k, at any point k, at any point k, if I take vertical, that is gk, instead of gx, it is gk. Now at this moment, what is the rate of change it is showing if I make a small change in k? Because rate of change is varying everywhere. If it is a straight line, then rate of change is constant, that is k. Kx, then it is k. But if it is x square by 2, then rate of change at every moment it is different. This is what we showed. First 3 we took an interval, then next 3 we took an interval, then next 3 we took an interval, and we saw the change. So change is not same if we go interval by interval. So if I have x square by 2, directly I cannot divide by x to get the rate of change, because rate of change is variable at each point. It's an algebraic equation, and algebraic equation and power of 2, not power of 1. So every moment the rate of change is different. So all along I cannot take same rate of change. If it is a straight line, the rate of change is same. But if it is a non-linear, then rate of change is not same. At every moment, rate of change is different. What is the rate of change of the x square by 2? Either I can say it is an algebraic equation, that is x, or that is x, not x by 2, that is x because I did the differentiation. Or you can ask at what point you want rate of change. At point k. Then if there is any k point on x-axis, at that point, if I make a small change in k, 1 unit of change, then at k, if this is the height, then k plus 1 unit of change if I see, then at k plus 1, what is the height? So if this is k, at k height is h, and k plus 1, the height is h2 and h1, then h2 minus h1 divided by k plus 1 minus k, that is 1. So h2 minus h1 is the rate of change at point k. Every places the rate of change is different. Okay, so if I, now it is clear, right? Means if this is x square, can you see this? This is going like this. So as we go far, it is becoming vertical. Earlier it was horizontal. Slowly it is becoming vertical. If it is becoming vertical, so later stage, the per unit change along x-axis brings high amount of change in y-axis. But at the beginning, per unit of change along x-axis brings little change along the y-axis. Okay, if that is the case, then rate of change is varying. At what moment, what is the rate of change? Better, it should be expressed again in algebra. So fx is algebra, integration gx is algebra. If I want rate of change, then gx way back to fx, again algebra. Algebra means there is independent component. It is variable. We cannot say 1 into 1, a scalar value, that this is the rate of change. It is variable. Keep changing the independent variable, you keep changing the different value. So what is, how I calculated integration nicely when I calculated the area. So if it is fx, I calculated the area and got the gx. If I have gx, then how I can get back the fx? Okay. Now, since this equation is the rate of change, what here rate of change is small, but here rate of change is sharp. It is going up sharp like a vertical. So if I want rate of change at any moment, at that moment, I see if I make a unit change along x-axis, then how much unit of change I see variation in y-axis. If I take 2 points, one point is x1, one point is x2, and for x1, the vertical, that is fx or gx, is y1, for x2 the vertical is y2, then what is y2 minus y1 divided by x2 minus x1? So if I say x1 and x, because at x I am taking a small distance, so it is y2 minus y1 divided by x2 minus x. Now whatever comes, I say this is the rate of change that is seen in gx at point x or at point x1. Okay, so this is the way we calculate the differentiation. So if I take a point, any arbitrary point x, and from x I make a delta x movement. For x, the vertical is fx or gx. If it is x plus delta x, then vertical is g x plus delta x. So g x plus delta x minus gx divided by delta x. That is the differentiation of gx at point x. If I say I want to calculate the differentiation of gx at point k, then f k g k plus delta x minus g k divided by delta x. Now here, if gx is a function, then derivative or rate of change that is seen in the function at point k, that is g k plus delta x minus g k divided by delta x. Okay, this is one analogy. So let's try with the x square by 2. So x square by 2 is a function. Then x I'll replace with the x plus delta x whole square minus x square divided by delta x. Fx gx plus delta x minus gx divided by delta x. This is the derivative at point x. So that is x square plus delta x square plus 2x delta x minus x square gone, delta x square plus 2x delta x divided by delta x. So it will become delta x plus 2x. Since delta x is in numerator not in denominator, if I set it to 0, means very small, then it becomes 2x. X square plus delta x square plus 2x delta x minus x square divided by delta x. So x square, okay, so x square gone. So delta x square plus 2x delta x divided by delta x. So delta x plus 2x, delta x plus 2x. If delta x tends to 0, it results in 2x. Personally, I don't like this concept at all. I think whoever is watching this video regularly, I don't like this delta x fundamental at all. If delta x is 0, still it has some value. Delta x plus 2x is the resultant. Delta x tends to 0 means still it has some value. I cannot say that delta x plus 2x is tends to 2x. So in differentiation of x square by differentiation of kind of x, we took x square 1 by 2, I left it outside, so it became 2x. 2 to cut down, then it becomes x. So if differentiation of x square is 2x, okay, we can try with other, then it will become formula like x to the power n. If I trying to calculate differentiation, then it is n into x to the power n minus 1. But this is the fundamental. Generally I don't like. Anyway, we'll try another way. Okay, now if there is a point x, from there I took another point delta x delta x. Okay, then g at x and g at x plus delta x. If I subtract gx plus delta x minus gx divided by delta x, it gives me differentiation at x. I can take from x, I can take left point as x minus delta x, 1 point, and after x I take, so that will be more perfect in a sense, the exactly x, what is the rate of change. So at x I take little left, at x I take little right, and then these 2 points I subtract and divide by 2 delta x. So this is at x, what is exactly the rate of change. This is another philosophy, I like it, this is better. So at any point x, I go delta x before, and any point x, I go delta x after. At these 2 points, what is the function? Gx plus delta x minus g x minus delta x divided by 2x, 2 delta x, 2 delta x. So that concept, if I proceed, then this will give me differentiation again. Let's try. So we have function called x square by 2. 1 by 2 I keep outside, x square. So it is now x plus delta x whole square minus x delta x whole square divided by 2 delta x. So it is x square plus delta x whole square plus 2x delta x minus, okay, x square plus delta x square minus 2x delta x. If I resolve it, it becomes 4x delta x. 4x delta x divided by 2 delta x. Then it comes as straightforward 2x. No need to minimize and tends to 0 or whatever. So now the differentiation of x square is 2x. This is better way, right? Okay, so the differentiation of x square is 2x. Now we had kept 1 by 2 outside, then x, then it is x. Okay, so differentiation of x square by 2 is x. That is exactly fx, that is x. Okay, Now, why we are trying to do this much? Many times we are not able to calculate the integration. Means if some formula is complex, then we are not able to calculate the integration. I don't know what is the integration of fx. Okay, integration of fx is gx, but I don't know what is gx. From fx I cannot calculate the gx. But if there is a gx, I don't know where from it came. If I do differentiation and it becomes fx, then gx is the integration of fx. We also call it antiderivative. This is the way we calculate antiderivative means integration. So if I find a gx function out of infinite function somewhere, and if I do differentiation and it becomes fx, then gx is antiderivative of fx. So this way also we can calculate the integration. Two way of calculating the integration. One way, through polynomial way, we know that x to the power n integration is x to the power n plus 1 divided by n plus 1. But somehow we are not able to calculate it. Now I'll find one function. If I do differentiation and it becomes fx, then gx is the integration of fx as per the whatever we have talked about derivative and antiderivative. Okay, so integration of x is, I don't know what it is, but if I do differentiation of x square by 2, then it becomes x. Doing differentiation is far easy because chain rule and those things come. It differentiation reduces the thing. If it is x square, then it becomes 2x. The degree of polynomial decreases. So if I go by chain rule or something like that, it keeps on decreasing and we get the value. If I go in chain rule in integration, it increases the integration. If it is x, it becomes x square by 2. If it is x to the power 2, it becomes x to the power 3 by 3. It increases. If I go in chain rule, it keeps on increasing. So it becomes difficult in integration. So sometimes people go with antiderivative. Antiderivative means they try to find some function for which differentiation is any function gx for which differentiation is fx. Now let's try for the integration of differentiation of sin x. If there is a if there is a fx and then gx. Suppose gx is sin x. What is differentiation of sin x? To get it fx back. So sin x means sin x plus delta x minus sin x minus delta x divided by 2 delta x. So sin x plus delta x is how much? Sin x cos delta x plus cos delta x sin x cos delta x plus sin delta x cos x, that is the sin x plus delta x minus sin x minus delta x. So minus in braces if I take, then sin x cos of minus delta x, sin x minus delta x, nothing but x plus minus delta x. So sin x cos minus delta x. So cos minus delta x is cos delta x itself. So sin x cos delta x plus sin minus delta x cos x. So sin minus delta x is minus x. So altogether it becomes sin x cos delta x plus sin delta x cos x minus sin x cos delta x plus sin delta x cos x. If that is the case, then first terms is ruled out. If first term is ruled out, then we have sin delta x cos x. Again, sin delta x cos x. 2 sin delta x cos x divided by 2 delta x. 2 gone, cos x into sin delta x by delta x. Cos x sin delta x by delta x. Since delta x tends to 0, so sin delta x also tends to 0. So these two terms, sin delta x by delta x, when delta x tends to 0, they become non-zero and equal when it is near the limit. So it becomes 1. Sine delta x by delta x where delta x tends to 0. I don't like this kind of fundamental, but whatever it becomes 1. So differentiation of sine x is cos x. We tried with the if there is a sine x function, if there is a sine x function, if there is a sine if there is a sine x function, then we take any point x and x minus delta x, x plus delta x, divide by 2 delta x. Generally, you will find in the book x plus delta x and x. So sine x plus delta x minus sine x divided by delta x. So that will term as sine x cos delta x plus sine delta x cos x minus sine x divided by delta x. It is very difficult. Sine x cos delta x plus sine delta x cos x minus sine x divided by delta x. Now you have to think so many things to bring it to cos x. So that is better alternative, where we have kind of at any point x we go left delta x, go right delta x, and try divide by 2 delta x. Someone can try now e to the power x, differentiation of e to the power x through both ways. One is x plus delta x, means e to the power x plus delta x minus e to the power x divided by delta x, and one is e to the power x minus delta x minus e to the power x plus delta x minus e to the power x minus delta x divided by 2 delta x. Whatever, people may say that first one was better, whatever is feasible. Okay, so this is the concept of differentiation we calculate. My way did not come. So my way is that can we do achieve differentiation, okay, without delta x calculation? Differentiation, integration, one of them you have to find. That's it. If I know integration of x to the power n is x to the power n plus 1 divided by n plus 1, then certainly differentiation is other way. That is x to the power, differentiation is x to the power n is n into x to the power n minus 1. So one of them if I find, then other I can find. Okay, that is the idea. Now if I know integration of differentiation of sine x is cos x, then I sine differentiation of sine x is cos x. So I know integration of cos x is sine x. No need to prove it. Differentiation of cos x is minus sine x, then integration of sine x is minus cos x. This is how we proceed. Now idea is, now this much we know. Now idea is, can we prove it that differentiation of sine x is cos x without delta x fundamental? Can someone try? Differentiation of sine x, differentiation of, if gx is sine x, can we get back fx? Okay, so if that is rate of change, that is fx is rate of change and gx is net collection. If net collection is sine x, then differentiation of sine x, that is fx, rate of change, is how much? Without using delta x component. Okay, so is there anyone who can calculate the differentiation of sine x, that is cos x, or at least someone can prove it that differentiation of sine x is cos x without using delta x component, like we saw, right? Sine delta x by delta x, we took it as 1. So this approximation personally I don't like. Okay, if can we do without this apply? For x square I did differentiation, then it came as 2x 4x delta x divided by 2 delta x. The delta x, it came as 2x directly. This is what I want. So now can we calculate the differentiation of sine x without using delta x constant, or at least can we prove that the differentiation of sine x is cos x without using delta x? So that is the idea.